Welcome to this explainer. Today, we're diving straight into a monumental discovery that is quite literally shaking the mathematical foundations of modern cosmology. We're looking at a massive anomaly that's forcing us to rewrite the textbooks and completely rethink the very fabric of the cosmos. So let's jump right into what scientists are now dubbing the spaghetti universe.
Recently, scientists set out to map the absolute largest structures in the known universe. And when you look out into that infinite dark space, our standard models tell us to expect a very specific, predictable kind of emptiness. But instead, they found a massive secret hiding in plain sight. They found something that absolutely defied the math, something that just shouldn't be there. Get this, instead of that smooth, uniform void we totally expected, scientists actually found billions of galaxies tethered together. They're connected by these enormous, glowing filaments stretching endlessly across the dark, forming this vast cosmic web. Basically, it makes the entire universe look like a giant bowl of cosmic spaghetti. Which, is a pretty fun mental image, right? Until you realize that according to our current physics, it absolutely should not exist.
This impossible, beautiful, and honestly highly unsettling finding was published in the Nature journal on June 24, 2026, and the second this paper dropped, wow, it sent an absolute shockwave right through the scientific community. Just imagine waking up and finding out the foundational rules of your entire profession have been turned upside down overnight.
Now, context is everything here. 100 years ago, science declared the universe is perfectly smooth at large scales. For an entire century, through decades and decades of physics, the scientific consensus rested completely securely on this firm assumption. Cosmological models just assumed uniformity everywhere. And then, June 2026 happens. This new Nature paper proves the smooth universe theory is entirely, fundamentally wrong.
Let's break down what was actually believed here. We are talking about the standard cosmological model. This framework is basically the absolute baseline of modern physics. It predicted that on a massive macro scale, the universe is uniform, smooth, and mostly empty. Meaning, no matter which direction you look, the overall texture of space should basically be identical.
But when we take that old standard model, the one predicting a smooth, uniform, empty space, and put it side by side with the newly mapped reality, the stark contrast is just dramatic. Instead of uniform emptiness, we are looking at highly organized strings of intricately connected galaxies. It's kind of like expecting to sail across a calm, flat ocean and suddenly crashing straight into a towering mountain range.
To understand why this matters so deeply, we really have to look under the hood at something called the lambda-CDM equation. This is the foundational mathematical model, the absolute bedrock equation we use to understand the mechanics of our universe. But here's the massive catch. For these immensely complex calculations to actually work out, the equation heavily relies on the universe being perfectly smooth.
Because this newly observed, stringy reality looks so profoundly different from the theoretical model, this core equation is in serious trouble. The lambda-CDM framework is beginning to literally crack and crumble under the heavy weight of all this new evidence. I mean, you simply cannot plug a heavily structured, web-like universe into a formula that specifically requires a smooth void. It just doesn't work.
And here's where it gets even wilder. A massive, overwhelming part of that standard equation relies on a very mysterious term taking up exactly 68% of the universe, with the remaining 32% being all other matter and forces. That huge 68% slice is what we call dark energy. According to the old math, dark energy was the crucial mathematical placeholder we absolutely needed to make the smooth universe equation balance perfectly.
So here is the absolute bombshell consequence that is keeping astrophysicists awake at night. If the universe is actually entirely stringy and not smooth at all, then dark energy might not even exist. That massive 68% chunk of the universe, it might be nothing more than a complete mathematical illusion. If the very foundation of the equation is wrong, the dark energy we basically invented to fix it might just be a phantom.
The reaction from the academic world has been, well, appropriately stunned. As one very famous, renowned Oxford cosmologist stated in direct reaction to this discovery, "This is serious." And let me tell you, that is not a phrase scientists throw around lightly. The implications of our dark energy models failing are incredibly serious for the future of physics.
So where does that actually leave us? We're now facing this cascading series of inevitable scientific events. Step 1, we have to accept the observational reality that the universe is fundamentally stringy. Step 2, because of that, we have to actively question the existence of dark energy entirely.
Which leads us to step 3, the most daunting task of all, potentially rebuilding our understanding of the cosmos completely from scratch.
But beyond the breaking math, there's a really deep philosophical mystery here. This vast cosmic web of golden filaments stretching across deep space is fundamentally way more structured and organized than any random universe model ever predicted. It doesn't look like an accident. Why is matter clinging together in these massive threads? It completely defies the random emptiness we expected.
As we wrap up this explainer, we are left staring into a deeply mysterious and awe-inspiring cosmos. The universe has literally been keeping this massive structural secret hidden from us for the entirety of human history. If we were this fundamentally wrong about the very shape and fabric of space, it forces us to ask one incredibly exciting question. What other massive truths are waiting out there in the dark? Thanks for joining me to explore this discovery. Keep questioning everything, and I'll catch you in the next explainer.